Eight. Hello. So today we will discuss about Heap Sort. Actually, Heap Sort is a technique of sorting using a special binary tree structure which is called heap. Using this special binary tree structure heap, we do the sorting. So before doing heap sort, we have to taste the knowledge about what is heap. Heap means suppose it's a binary tree. Binary tree means each and every node can have at most two children. So and that becomes a binary tree when each or every node in the tree has only two children, maximum two children, then it is known as binary tree. Now, binary tree, when this binary tree is called heap, such that each subtree of that binary tree, if it is like that, the each subtree, the root node of the each subtree is greater or equal than the then all of this all the nodes of that subtree, then that is called heap. And if we consider a heap, means if we if a binary tree is like that, that for every subtree the root node has value greater than or equals to its children, then it is called a heap. And if you consider this, that means the root node will have the highest value. And when the root node has the highest value, then it is called a max heap. And when the root node is the root node of every subtree is like that, that its value is less than or equals to both of the children and both of the elements of that subtree, then it is called to minimum heap. So if we consider minimum heap, then the root node will always contain the lowest value among all the nodes in that tree. So that is the concept of a heap. So how this heap operation will be done in computer. So in programming, they are represented as in an one-dimensional array. Suppose the zeroth element, suppose there are 10 elements in an array, and we need to sort it and using heap sort algorithm. So heap sort algorithm tells you that if it is a max heap, then the root of the tree will always contain the highest value of all the nodes in that tree. So we can move that highest value to the last. We can move the highest value to the last of the array. Then considering the tree, excluding that highest value, considering only the nodes of a remaining tree, again I will make a heap of that remaining nodes, and the highest value of this remaining tree will be moved to the highest position within that particular size. Suppose first when suppose the size of the array is 10. So after creation of it, the highest index element will contain the highest value. Then we will contain the array of 1 less than value, of size 1 less than value. So there also, so first we will create a heap of 10 elements. Now we will consider the heap of 9 elements, remaining 9 nodes. And after creation of a heap, the last index of that array will give the highest value of that remaining nodes. In this way, if we consider the decrementing the index of the array one by one and up and go on continuing the creating a heap of that reduced array size. Then after the creation of each heap, the maximum value will be at the rightmost location. So first the highest value will be stored in 10. If array size is 10, it will be stored in ninth index. Then we will consider the array size of 9 elements, and the element which is highest among this remaining 9 elements, that will be shifted to the right just before of the highest element. Then we will get the second highest element. Then we will consider the array of remaining nodes, that is 8 nodes, and among these 8 nodes which has the highest value, that will go to the right position. So we will get the next highest element, and in this way, if we go on in this way, so we will get a list in sorted order, either ascending or descending, depending on the type of heaps we are using, either maxit or minit. So now it's clear that what's a heap means. It's a spatial binary tree, and so to do heap sort, first we will create a binary tree. Suppose an array will be given, but we will change the position of the elements within that array so that it will be a heap. And when it is heap, then the root node will contain the highest value among all those elements. So we will now replace that highest value, and considering the remaining 9 elements, again I will create a heap among those 9 elements, and the highest value among them will be there at the root node. Again we will replace it by the node of lowest index node, and again we will go on creating. So actually, if it is and be done on Fane and Heapsort, then it will be very easy to understand how Heapsort actually works. So each time there is two operations. One is create a heap, then next operation is eliminate the root node. Then again take the array size one less than the previous size, and again create a heap among them, and again eliminate the root node. So in this way, we will get the highest element and the second highest, then third and the highest element in this way, and we will get a sorted array. So for that, so two operations is when you require one is page of this, then deletion of the rows node, and this can be done by decrementing the array index, decrementing by 1. So for the example, we are taking our array size of 10. And also one thing, that how the tree means it's a structure where there is parent for any node. A root node has no parent, but any other node which are not root nodes, that must have a parent, and the least node which does not have any children. So in array, how can we understand that which one is parent node of which children, or what the children of a node? So for that, we'll use one-dimensional array sorts to represent it by an one-dimensional array. Suppose the zeroth index array index will be and so many arbitrary value like 1000. Why this is required? Sometimes it is required for algorithm termination. So that can be any value, like for example 1000. Okay. Now we will start on storing the elements from index 1. So as we are taking the array size of 10, it will go up to index 9. So 0 to 1 to 10, and because 0th index is already reserved, and there's a remaining there for storing 10 numbers, we need 10 more locations. So total the array size in this case would be 11. And if we consider an any tree, binary tree, the root node is scored at level 0. The next children of the root node is scored at level 1. Then the children of those nodes which were at level 1, so we will get the nodes children of nodes level 1 at level 2 and level 2. So, similarly, the children of level 2, all the nodes which are children of the nodes of level 2 will be in level 3. Now, so at level 0, only one node is there. So, so number of nodes in level 0 will is equal to the first 0 equals to 1. Then if it is level 1, then the maximum number of nodes in level 1 can be 2 to the power 1 equals to 2. If it is the level 2, then maximum number of rows in level 2 can be 2 square equals to 4. Similarly, for level 3, the maximum number of nodes will be 2 to the power cubed upon say. So that is a pattern, or that is the, that is how we are calculating binary tree. Now, suppose the root node is to that location index value 1. So each children, it has one children and one right child, one left and one right child. So left child will be stored at location 2, index 2, and right child will be at location 3. Again, the children of node 2, index 2, will be at location 4 and 5. That hence, if the parent is at location, then its left child will be in 2i location and the right child will be in index at which index to 2i plus 1. In this way, we can identify that which node is parent of what node, or which is a children. Suppose we for errors 10 is a 10 is an element with who is a parent node. After that, no other node is there. Suppose the 10 last element, if index number is 10, so its parent will be 10 by 2. That means if the node current node position is null, then its parent will be in location I by 2. Then its parent will be location in I by 3 integer value. They applicate the integer. Suppose the children is node at index 9, so its parent will be at location 9 by 2, and we applicate the integer value, that is 4. And similarly, for both 8 and 9, the parent is same, that will be at index 4. So in this way, we are getting the relationship, how to get the parent and children relationship when a binary tree is stored in a one-dimensional array. Okay, now this is clear. So first we will create to discuss Heap Sort. First we will create whether the array from that array which is that will be finally stored as binary tree, but we will construct a heap from that binary tree. That is the first step we have to do. Then second algorithm will be that how to delete the root node from each and every heap, and the size of heap will go on decreasing one by one by decreasing the array index one by one of heap. So two algorithms we need. First we have to create a heap. Number 2 is we have to delete the root node of every heap. Okay. So suppose first heap is created, then that is creation, the algorithm will be there. Then the root will have the highest value if it is a max set. So I will shift that highest elements at the end of the array. Then we will decrement the array size by 1. Then from this 9 element, again we will construct a heap. Again we will construct a heap by eliminating the root element. How we can do the elimination of root elements? We just decrease the array size 1 by 1. So it will now be considered as an it will be considered as to construct a heap of 9 elements. So in that 9 elements, when we again form a heap, then again the root will contain the highest value, and that will be at the last position. So it will be the second highest element. Again, we will decrement the NSI. So we will discuss two main algorithms for Heapsort. One is creation heap. Number two is elimination of root node from the heap. Okay. So we will going to it. And next part, otherwise we do it with so many bamboo. It goes so much well, so I will stop here.